Hello everyone, welcome back to my channel. Hope you all are doing good. Now we are going to learn about the encoding techniques of Pandas and we will start with our topic today. So let us understand encoding, guys. What exactly is encoding? Let me quickly take you to whiteboard and explain you what is encoding technique. Okay. So we have in categorical data, what we have? We have two type of categorical data, right? One is nominal and another is ordinal. One is nominal and another is ordinal. In nominal, just take a case of example as gender. Gender will come under nominal, right? Because it does not have any order. Like I have already explained, ordinal means it is going to, follow a order or a format of a sequence of data, correct? So here we have nominal, right? Gender. Gender I have M and F. So what our encoding will do when we will get this encoding, right? When we'll apply encoding, if this is your data set and if you have a gender column present in your data set, right? How it is going to convert it? It is going to convert it something like this: gender underscore male, one column, and gender underscore female, another column. Okay? And what it is going to do, it is going to take, for example, if you have 1,000 rows, okay. So this is going to give you 1 0 0 0 0 0. Consider that in if this column, okay, this particular column has male and this, okay, take this example, please. So here we have male, right? We have male and female. So what it is going to do, it is going to convert something like this. Okay. It's going to convert something like this, where your male will come, here it is going to convert it to 0, where female will come, is going to make it, where male will come, it is going to make it to 1, where female will come, it is going to make it to 0, or it is a vice versa. Where, consider that here like this, your column is having like this, right? Male, female, male, like that. So here it is going to replace it to 1, here it is going to 0, 0, 1. Like that it is going to come, throughout your column. So here 0 is 1, it's 1 is 0. What I am trying to say, every time when you are working with one-hot encoding, one hot means always one bit, minimum 1 bit will be there in your column. So just take A, B, C, D if you have a column, and if you have 4 rows in that particular data set, and how it is going to be presented? Is going to be presented something like this, right? Like in case, just let me draw it, how it is going to be. If I am taking first A is a 1, then 0, then 0, then 0. When B is coming, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. And this is how your data is getting distributed, right? Like when we are talking about encoding, hot encoding, this is how your data is getting distributed. So what I'm saying that I have 4 columns and I have these 4 columns, I have 4 rows, and this is how I am getting. That means if I have the whole column, I have only A, going to be like this, consider like this, it's like this, right? So It is like, just like, we have uh, you must have seen that and or table, when and or you are drawing it in a tabular format. This is how it's looking, right? So this is the same thing. So the one hot means, if you see each column is having one as a value, as one bit. One hot encoding means one bit. One bit would be present minimum in your column. That is how the one hot encoding concept came up. And so one hot encoding is again where it is going to be applicable. So where you are seeing most of the time nominal data. Nominal data means either gender, like male or female, or yes or no, right? Yes or no, those cases as well. Or you can say that you have male, female, children, those cases also you can apply nominal. And one more concept we have to understand. So when we're talking about a one-hot encoding, if this, just understand, if we'll remove one, like if we'll drop one column, are we be able to understand that what are the values are going to be coming in female column? We are, right? So here we are saying, okay, if it is 1, that means it is going to be 0. If that, like, we should be able to know, okay, 0 is there, that means, okay, there 1 will be present. Okay, here 1 is there, that means that 0 will be present. So in this case, we are always dropping our first column. We are dropping our first column because it's going to be increase your linearity towards machine. It's going to increase your linearity towards machine. Linearity means it's going to be completely collinear, like it's going to be overfitting to machine. It does not need, right? Because it's self-explanatory. Okay, I have 0, 1, 1, 0. That means the other column must be having 0, 1, 0, 0, 1. That is why we are dropping our first column, and this is a ground rule of encoding when you're performing one-hot encoding. Now, let us understand. We understood this topic. We will go ahead and see that implementing in real. Okay. So here you can see I have taken again Seaborn library or Seaborn dataset. Same time, I have imported my Seaborn library, import Seaborn as SNS, and you can see I have a Titanic dataset present here, so I have taken it. Here, data I am taking, I am loading the dataset Titanic. We are just loading with load underscore dataset, right? In CSV, you are doing read underscore CSV. So here I am getting head of it. And you can see I have columns like survived, P class, sex, or which is gender, age. My bad, guys. I need to run this library first. Then I have to come. Now let me run this again. We have age of each and every person. Then we have SP, that means sibling and spouse, right? We have parch, pair, embarked. Embarked means these are the cabin type. Okay. Class, who, adult male, deck, embarked down, alive, and alone. And deck means again it's a cabin. Like what are the type of, like what is the kind of class related to that? And embarked term means like from where people are getting up, or from where people are onboarding to the ship, right? That, like, it is telling Southampton, and these are the different places, or these are the different ports from where they are onboarding, alive or not, after that incident, and who are alive and who are not alive. Complete almost all data points of those survivors or non-survivors of Titanic incident. Now, we understood, okay, here I have shown the difference between nominal and ordinal. Nominal, few examples, like I said, gender, then non-binary and other, favorite ice cream flavor, vanilla, chocolate, strawberry, mint. This does not follow any order, right? Ordinal, customer satisfaction level, unsatisfied, neutral, satisfied, very satisfied, economic status, low income, middle income, high income. So where hierarchy is coming at that time, you can consider that as an ordinal. Now, we will understand. So here I am just showing the column. It is going to be easier for me to copy the columns at the same time. That's why I've taken it. We are performing one-hot encoding. Now we will understand how many nominal columns are present here. Survived is a target column, guys. Survived means we are understanding after that incident how many. So whenever you are working with machine learning, you will be having always a target column. So here we are considering survived as a target column. That means we are telling that we want to know, we want to analyze by our machine that how many people survived that incident. And it will input give future data set whether it is going to give me the correct output or not. Right? So here my survived is a target column. Now we will see P class. This is a numeric column. This one gender we have, and that is our nominal column, right? Age numeric column, SIB SP numeric column, patch numeric column, fair numeric column, MBART can it's a nominal column because it does not have any does not have anything as such like any categories or any hierarchies, right? Class can be your ordinal column because it is first, second, third. Right? Then we have something called adult male where it is telling true or false. This is a nominal column. Deck, we have a nominal column. Embark down, nominal column. Alive, nominal column. Alone, nominal column. So I am taking everything, like I am considering everything here. All those like gender, who, adult male, alive. Let me see. Gender, male, alive, alone. All those things I am taking. And I am implementing that. You can see how we are implementing, guys. We are taking pd.getDummies. GetDummies is a method. With that, we are implementing our one-hot encoding. We are inserting our data, and from that data, what are the columns I want to convert it to one-hot, or I want to apply one-hot encoding to those columns. Then drop the underscore first. Like I said, we have to drop the first column for avoid multi-collinearity. Drop first equal to true. Now let me run this. So you can see I got all my values just like I said it. It's converting gender underscore male. It is dropping the female column, and based on that it is giving me the male column. And who man, who woman, because we have children as well, so it has removed that column. Drop first, who woman, and adult male underscore true, right? Where we have adult male true and adult male false. So it has kept only one column and it has dropped another because it's self-explanatory. Alive underscore yes. As we have alive underscore yes and alive underscore no, it has dropped alive underscore no. So we got our encoded like one-hot encoded values. Now we are like again the same thing. I'm skipping in head. Now, so here we understood. Okay, we are getting the immediate nominal values. Immediate nominal values are your gender, right? Then we have alive, alone, and adult male. These are your not adult male. I think who is also there. If I consider who, yeah, gender, who, adult male, and alive. These are your immediate, like immediate this thing, right? Immediate and like immediate nominal values, correct? Now we will see some concept is there called label encoding, and label encoding can be used for one category above columns where we have these are your immediate nominal, right? But if you see this embark down or this embarked, all these things, we have multiple values. And we like it. I can say these are labeled data. Labeled data means it has some values, or it it is flowing with some different values, different set of values, and it needs to be treated. And the same thing, like I'm not saying that we cannot do table in one-hot encoding for those columns, but I want you to try that, give it a try. But here I want to show you that for those columns like alone, embarked, and embarked down and embarked, I can implement label encoder as well. So what I'm trying to say in short, that nominal columns can be either, like you can either use one-hot encoding, which is a very easier concept, and you have to just do get dummies and you will get it. And we have something called preprocessing, like label encoder. Preprocessing, we have sklearn, label encoder we have, and that one you can implement. You can just do fit and transform. It is going to give the output. And when you will do that, you will see the difference based on the count of, or the number of values present, or number of labels present. That is why we have considered it here, and we will see the output what we are getting. So here I have taken an embarked column, and I am this is how we can get it, guys. So let me come back here. sklearn.preprocessing import label encoder, guys. So yeah, I'm just running it. Again, I'm importing my Pandas library just for safer side. Again, the same concept, guys. Whenever you're using preprocessing libraries or preprocessing classes, you have to use, like you have to initiate or instantiate an object of it, correct? So this is the object I got it, LE, for that class. And here I am taking embarked column, embarked down column, and alone column, and I am running it. When I'm running it, I am getting different encoded value of it. And now you can see that my dataset is converted to encoded. Like here I have taken encoded dataset, right? Now I'm taking the same encoded dataset and I have transformed it to label encoder. Now let me see the head of it. So if you see the head of it, all these numerical columns are staying same. However, come this side, you can see the difference what I am trying to say. Let me remove skip 20. So if you see here, guys, see here, what is the difference I am getting between get dummies and label encoder? Both are same. However, I have different labels here, like I have different values here, just like, different, more than 2 inputs I have. That is why I am getting, it's a kind of ranking system it did. The ranking system it did, and it has given me this kind of output, 2, 0, 1, like that. However, in case of true or false, yes or no, male or female, man or woman, in those cases, it is just giving me 0 or 1. However, it has ranked those things and it has given me the outputs, right? Similarly, we have embarked down. Embarked down, again, we have, I think, 3 towns which we have in our dataset, and it has labeled that to 0, 1 or 2, and it is giving me the output. Similarly, alone, guys, alone we can do one-hot encoding because it has just 2 values, and it is just going to give you the same thing. Just like I said, you can either use label encoding or one-hot encoding, same type, or any numerical values. But if you have heavy nominal values, in that case, you can consider label encoding in that case. Then again, when I am converting those columns to encoding columns, right? What is the next step I have to do, guys? I need to drop my original column, right? Because I do not want them to be there in my dataset, and I do not want them to lead to machine, right? So I'm running it. When I'm running it, again, I'm getting, you can see all those columns, embarked down, and alone are gone, and I'm able to see only encoded alone, encoded embarked down, and all whichever we have encoded, those values we are getting. Now we will see info ones of encoded, and you can see we are getting some null values, right? In age we have null values and we have deck also null values we have. So first I am filling that age column of data encoded data set with mean of it, and you can see I did it, and I am getting the info again, and you can see that it is filled with that data, right? If you do info, it is going to give you the correct values, right? Correct column counts, how many, or correct row counts, and by seeing those row counts you will be able to know, okay, it has null or not, right? So now my age does not contain any null. Okay, now next, what is that? I have deck, and deck is having it's having null values, so I am getting mode of it and I am filling it with mode. You can see again, finally I am getting my data without any null value, right? Now I want to transform. Again, label encoding, I want deck, I have, right, more than one value, and those are labels. It is not like gender or something, correct? I am taking label encoding, and I am fit and transforming that, and I am getting okay, let me see that. Yeah, encoded deck, you can see we are getting all values, like it has, I believe, A, B and C, and for all C it has taken 2, and A it has taken 0, B it has taken 1. Let me just take 20 just for verification. Yeah. Oh, it has more than, I think, more than one value. There's more count, I believe. Let me just see that. Data. Let me get the unique value of it. Just. Okay, so it has almost 6 categories. Oh, it has been converted. That's why I'm not able to see it. Let me see from the original dataset here. What is the unique values we are getting? Data dot. What is it? Embarked. What is that column name? That drawing. We are trying for where is it? Yeah, we are trying for deck, right? Now let me go back here and see data dot deck dot unique. Oh, we have A, B, C, D, E, F, G. Okay, we have 7 objects. See guys, I told you, right, in these cases we have to be very careful and we have to consider label encoding because it has more than one label, right? Now I'll get back. So we have 7 categories. That's why I have taken it, the label encoding thing. Now we will see here. So here we got our text now. Now my duty is to remove, like now I am using my class label encoding to class as well, and I am getting the output like this and getting the head. So finally you can see how my data is getting transformed slowly, right? And I am dropping all the columns, both deck and class. And let me see what is the final output I am getting after doing all these things. So yeah, you can see here all columns I got, but all are in encoded format, right? All are in encoded format, correct? Now, what is my next step, guys? Once we are getting that, we have to scale it down, right? Now let me run that min-max scaler. Okay, let me see column names, and this is how I can implement my min-max scaler. And this is what I'm getting the series, and this is how I'm getting my output, right? So basically, when after converting these things, right, like after encoding, you can skip those columns from from your scaling because it's already coming between 0 to 1, right? we do not need it, but yeah, you can take the heavy like wherever you have implemented label encoding, because it has more than one label, right? So you can consider that. And wherever you have this basic like starting level of nominal data where gender is there, then yes or no is there, male or female, then all those places you can consider nominal, and you don't have to scale it down because it is already coming in 0 to 1 and it won't be affected. So we can see it is not affected, right? Only these values are affected, right? So yeah, so now I can say that my data is ready for giving input to my machine, right? And this is a kind of, this is your regular process, guys. This is how you will proceed with your regular projects. This is how you will do cleaning. You will fill the data. You will draw the data. You will draw the chart and all. So yeah, this is what I was expecting from you guys to practice and proceed, right? Okay, so yeah, till that time, see you. We are ending our one-hot encoding and label encoding topics. We'll meet you. We'll meet again. Well, that would be all for now. We will cover further topics of Pandas in our upcoming video. Till that time, please take care. See you. Bye. Please start subscribing, like, share your comments, share your valuable feedback. That will help to grow all together. And see you. Bye.